Hello everyone, this is Bradley. Recently I've made a procedural stock market and people asked for a tutorial of it. So today we're going to make that more accurate, more complex, and we're going to probably do an animation with it. So let's start. So here in Blender, as always, I'm going to use the presets which you can download for free from the link in the description. And although I'm using 4.1, but you should be able to apply the same technique in 4.0 or even 3.6 and before. Here, let's go to the noding. Let's add a plane to hold the geometry node tree. And I'm going to add a curved linear, which is essentially just a resampled curve line. And I'm going to instance points to get another set of points. Another set of curve line, but this time I'm going to make that into the z-axis, and I'm going to uncenter it. I'm also going to change the length. This is very important because I want you to understand that I'm instance a curved line with 1 meter, and its scale is 1/1. This means that if the scale becomes 2, then it also becomes 2 meter. This is very important because while we're changing the scale, I'm also going to offset this curve line. The basic concept here is very simple, that if I have my initial curve line about 1 meter, then the second curve line should be offset by 1 meter, and the third curve line should be offset by the length of the second curve line. This is like stacking books. And there are many tutorials about it. Basically, they are using a node called accumulate field. This node is essentially just the accumulating numbers. If I have a series of numbers, 0, 1, 2, 3, 4, 5, and I start from 0 to add 0, then the output is 0. And 0 plus 1 equals to 1. 1 plus 2 equals to 3. 6, 10, and so on. So you just accumulate these numbers, and this is your leading number. The trailing number is that you basically offset all these kind of numbers by 1, 0. So it looks like 0, 0, 1, 3, 6, 10, something like that. Okay, so this is kind of idea. And this will help us to offset these lines while scale these lines. So let's take a random value, and we can use a combine XYZ and another combine XYZ to change both offsets and the scale. So if I'm using this random value to set the height of my curved line, then you can see there is a variation of their height. And I'm going to offset these curves with this accumulated height so that they will go higher and higher. And here I'm either using leading or trailing. If you do not really understand the logic behind, you can just try either of them and to see if it actually works. Leading doesn't really work, but the trailing will. So this is what you are getting. Okay. But because our random value is from 0 to 1, so it actually goes higher and higher. And here I'm going to change this into the step mode, so that the step distance from this curve line is like 0.1. The benefit of it is that if I'm increasing the count, then it will keep increasing the amount of whatever stuff you have. Okay, you may also uncenter that so that it always increase in one direction. Right now, everything is always rising because our random value is from 0 to 1. What you can do here is that you can take a negative value. So I have a negative value, I have a positive value, and I set that to 1. So this is original number is 1, I output -1 and +1 for this minimum and maximum. You can also increase the size, whatever. But basically, this is the concept. And then you can increase the count. This is a completely procedural stock market, and you can just changing the seed of this random value to change whatever. Okay. Before we go into more advanced version, I just want to remind you that you can tweak a little bit with this stock market. For example, you can add a value, and this tiny value will be accumulated over time. So if you are adding a value, it means this stock market, no matter what it goes, there is a final trend of increasing. Instead, if you add a negative value or subtract a value, then it will constantly decreasing. Okay, so this is a kind of idea. A kind of a quick ways before we go into more advanced version of it. Next, instead of manipulating everything with a seed and a very crude trend, I would like to use a set pattern. So let's go with a curve line and a path. And I want to use this drawed curve to guide the trend of my stock market. So maybe something like something like this should be enough. Okay. So we're going to do something very different. And the first thing I'm going to do here is that I'm going to import this curve into my node tree, so that even if I hide this curve into another collection, I will still be able to visualize that. And we're going to forget what we've done earlier, but I'm going to start a little bit different setup and to visualize what we are having. So this is what we're having now, and it's very different from what we had previously, because our initial curve line is just a straight line on the ground. So there is no offset. But right now you have some inherited offset. That's why when you're instancing these curve lines, they're just going up and down. And here we can increasing the amount of curves by resample it. So we have more curves to actually visualize. And basically what I'm doing here, or what I'm going to do, is that I want to know the height difference from points to points. And then I can use this difference to set the height of this curve line. So here what we need to do is that we need to know the position of all these kind of points, and we need to know their height by using this separate XYZ. And I'm going to offset the height so that I can always compare the first one with the second one. So what I'm going to do is that I'm offsetting the points in curve, and I'm offsetting -1, so that's when I'm having an evaluate at index, at this offset index versus the index I'm having right now, I can subtract to compare these two values. So this is the height of the second point, and this is the height of my current point, because one of them is offset along the curve. So I get this height difference, and I can make that into a combined XYZ. And if I plug it into the scale, then you can see this is immediately what we are getting. Everything is already being offset, and they are scaled properly to show a pattern that we are looking for. Right now, we have finished discussing two concepts. One is that we're using accumulated fields to do this completely random stock market. And the second is that we're generating a stock market following a predefined patterns using these offset methods. And now we are going to combine these two setups together. Just assume that we have a predefined curve which already contains all this kind of noise. Then this setup will still work because it's offsetting all this kind of position and calculate the difference in height. So what we're going to do here is just to simply put this random value into the offset, then immediately you will find that it's working. All these kind of stock markets are touching head to toes, like what the real stock market is doing, but they also contains kind of randomness. So this is very nice, and you can clean up this node tree a little bit. Now, if you compare these trends with our initial curve, you can see they are very different. One reason is that previously we add a constant decline, so now we can remove that. So now you can see they are very similar to each other. And sometimes when you add too much randomness, they of course will look a little bit off, but then you can decrease the randomness. If you make that into the 0, then it means you have no randomness. You are completely following these trends defined by our curve. So it's up to you to decide how to set all this kind of stuff. Okay. And next, we're going to make that into a mesh. To make a curve into mesh, we basically just bevel curve, and it's supposed to have kind of a thickness, but we don't. This is simply because that the scale we input is 0, 0, whatever. So we put that into 1, 1. And then I take a curve linear, because instead of making that into a tube, I'm just going to make it flat. And you see that because we're sampling on a spline, so the distance from points to points is not equivalent. This is kind of very annoying. So what can we actually do in this case? To make these curves into mesh, we basically do a bevel curve, and it should make a curve into a tube-like structure, but it doesn't happen. This is because the scale should be 1, 1, whatever. Okay, and then we can decrease the radius and so on. But no matter how you tweak that, you realize that the spacing is not equivalent. This is because the resampling method is along its curve. And even if you put that into the length mode, you find it will not really work because it's along the length. So to fix this kind of problem, I think I'm going to use curve linear. So we start with a curve linear, and I'm going to increase this length, trying to cover the areas. And then I'm going to take a break cut, and we take a set position. So we are recasting to this path, and we use the hit position to redefine our position. Immediately you see this warning sign. It says curve is not a supported geometry type. So what we do is you make that into a mesh. Just a tiny little bit is enough. Okay. And instead of shooting the ray downwards, where you hit nothing, you should shoot it upwards. And actually you should be able to see it. So it looks like this. And then you just increase the cut. You realize there is a sharp line. This is simply because there is a point which is not hitting anything. But Anyway, yeah, you may use these hit as a selection. So once you've done that, you can just use this set position to replace. So now you have everything being done. If this curved linear is not being hitting anything, then you will have weird stuff, but this is fine. There will be a problem that because we're starting from the ground and we're shooting ring up to sky, if my guide curve is below the ground, then you realize it's actually not working. Yes, you realize it's actually not working. There is a part which is on the ground. So to fix this kind of problem, my suggestion is to take this position and just subtract a high value so that the evaluated position is coming from below, and then you shoot a ray upwards, 001, and the ray length is 100 meters. So you must hit something, hopefully, and you hit this curve and finally result in these kind of patterns. And more importantly, because we start from this spline with a known spacing, you can either use the step or stop mode, does not really matter, but it will fit hits and being remapped. And finally, you're adding the noise and scaling everything. So this is the setup. Okay. Next, let's add some statistic markers. That's actually a little bit tricky part in this particular setup because the origin of the instance is at one end of it. So if you directly instance something, that you might end up something like this, which is generally not good. So what I'm thinking is essentially you want to have an instance which is in the middle of this whatever stuff. Okay. So here I need to know the bounding box of each instance. So we take an instance bounding box. Internally, it actually realizes the instance from these instances to geometry. This is very important. But alternatively, we get a instance bounding box with this minimum and maximum listed as in diamond shape. Okay. So basically, if I have this bounding box, I have this corner as maximum, this corner as minimum, and I just need to subtract these two and divide it by 2. Then I have the center point. So here I'm just going to take this maximum to subtract the minimum, and I divide it by 2. I get a center point, and I add this center point to the minimum so that there is an offset to the middle. Okay, we can use a 3D viewer to actually confirm our vectors. You can see it's working. There are lots of instances generated in the middle. So here we just need to take mesh 2 points, and we set the new position, and we merge by distance, and we instance on points, and you can set another curve linear, this time into the z-axis. So you have a lot of vertical lines. We join geometry. So this is what we're getting, and you can definitely give it random numbers. Let's say randomness, and combine XYZ 11Z. So you have a kind of random number, and you can use the average number to control it. So now you have this kind of statistic markers. Obviously, you are going to give it a kind of a mesh volume. So we bevel curve. And here, instead of all these kind of cube structures, I wanted to like going with kind of linear trend. So let's just use a quadrilateral. So make it kind of grid-like. And I can do the same with the previous bevel curve. Okay. So finally you get something like this. There are some parameter issues that you can tweak more carefully when you are working. But basically, I think it might be better in this case to make a radius to be 1. But then you have to tweak all these kind of tiny values. But you can do this at your free time. Yes, basically this is it. Okay, you can make all these numbers more accurate, but I don't want to spend the time on this. As we finish the general mesh setup, let's start with the shader. We basically need to give one color when it's going up and the opposite colors when it's going down. And you can see that this up and down is actually determined by the scale. So we just need to store a named attribute. And you can name whatever you want. But here I'm just going to name that as C. And at the end of node tree, I'm going to put a material. Here in material editors, let's add a material. Okay. And within shader editor, I'm going to import this attribute C. And if I visualize in material preview, you can see there's a black and white, but there are also some grayish. So I'm going to clear that up, use a greater than, and I compare with 0. So you can see there's absolute black and white. And I'm going to take a mix color. And one color is red, the other color is green. And now if you look at that, you can see that green is going down, red is going up. We can make that the opposite, so use less than. Okay, so I think this is fine. But you also realize that the statistic markers is not having the same color changes. However, if you try to visualize the attribute, let's say our previous attribute is actually C. You can see there is a black and white, but somehow it's just not being shown in shader. This is simply because these are instances, so everything is identical. You realize the instance, then immediately they becomes independent from each other. So they will have their own colors. And this is basically it for mesh and shader. At last, I just want to briefly discuss the entire idea of animating it. There are many different ways to animate that, but the way I prefer is to actually control this scale. If you multiply the values by 0, then you can see everything disappears, and you multiply by 1, then you can see they are scaling up. Okay, this is one way to animate that. This is also true for all these kind of statistic markers. You just multiply the scale by 0 or 1, then you can see it becomes longer and shorter. Okay, so this is just an example. So here, what I'm going to do is just I'm going to use a directional fold, and let's get an empty. This is just an empty object, and I can make this empty into an arrows, and I use this fold to control the scale of it. Okay, here you notice the problem that you realize they are going the opposite direction of scaling. But technically speaking, this should start from this side and going downwards, and so on. So I think to fix that, you just reverse this index, and you can see it's working. Okay, Oh, this is an easy fix. Okay. And if you want to make this fall for sharper, you just can use a color ramp to make this 0 and 1 value a little bit sharper. So decrease the transition times. So you still have this kind of increase and decrease, but it becomes much faster and sharper. Okay. So this is kind of idea. And this is equally true. You can just plug the same values to the other scales. So now, if you look at that, this is what we have. Okay. So this is just an example. In reality, you can make that more complex. For example, you can add the inertias using the inertial offset or inertial deformer. But here I would say this is probably it. Let's add a inertial deformer. I think it should be fine. But we need a keyframe to make this simulation work. So let's start with this locations. And if I play this animation, I'm not sure if you can actually see it clearly or not, but you can see actually this is there's a bouncing event occurring for this scaling up event. So this is basically it. This tutorial is much longer than I expected, but the concept is not really difficult. It's just the more you want to achieve, a more complex setup you need. So basically this is it. I hope you enjoyed this tutorial. I'll probably see you next time. Bye bye.